Hi, everyone. A big welcome to DevFest Singapore 2024. It's awesome to see so many of you here today, and thanks for being part of this event today on your weekend. And a special welcome to everyone joining us from Asia Pacific via our live streams. Although you're not here to join us in person, we still hope that you get most out of our presentations today. And please feel free to join the conversations on live chat and ask any questions if you have, as we have Google Cloud moderators online to answer your questions if you have any. So my name is May. I am co-lead of GDG Singapore. I am also a software engineer like many of you here. And today I'm here on behalf of GDG Singapore and GDG Cloud Singapore to welcome you, thank you, and supercharge you so that we can start the day off with a big, exciting energy. Yeah. So before we begin, first things first, please be noted that this event will be photographed and filmed for promotional and archival purposes. So we assume that by attending this event, you consent to be photographed and filmed, and you agree that your image may be used in the promotional materials in the future. So please be noted on that. And we have 3 important QR codes, which you can take photo now to keep it to yourself. So we have QR codes for event photos, which you can upload any photos or videos you take today, or download any media that we take today from here. And the one in the middle is for the agenda. So we have the same QR code on the backside of your badge. So you can scan this QR code and it will take you to the full agenda for today. And then we also have a QR code for DevSpace Telegram, which you can join and then catch up with us. So now let's talk about what is DevFest. Why is it so special? How many of you were here last year? Really? Okay, that's less than what I expected. Okay, DevFest is all about celebrating tech and community spirit, and it's organized by passionate volunteers like myself within Google Cloud, GDG Cloud Singapore and GDG Singapore. And it's where you can explore the latest technologies, including AI, and also where you can get the latest news from the tech visionaries. Also, you can get some practical tips to take home. And this year is particularly special as we celebrate 15 years of DevFest. So DevFest Singapore and DevFest itself, and also the GDG Singapore and GDG Cloud Singapore, which is our community here, celebrates 15 years this year. And then I want to highlight a huge shout out to our amazing designer who created this unique badge. I think everyone has received one of the badges. So our designer created this badge to celebrate our 15 years with 6 different collections that featuring iconic Singapore landmarks and DevFest Google products. I think this is perfect way to celebrate our DevFest 15 years together with our local developer communities. Okay, let's look into what's happening next. So after this, we will have opening. Okay, the fonts are a little small, but I think you can still access this agenda via the QR code you have right behind your badge. So after this, we'll have opening keynote session here in developer space. And then after that opening keynote, we have 2 locations which you can choose from. So we have 2 different tracks running in parallel today. The one will have developer space, which is where we are now, and another location is Himalaya. That's the other side of the space. So you can get there by crossing the lift area. So just cross the lift area where you entered from, and then you'll just see it right away. So each of the locations will host 3 sessions, very exciting sessions, back to back until 3:50 in parallel. And at 3:50, we will start 15-minute break. And that's when I'll say goodbye to our live stream viewers. And after the break, we will resume the sessions in both of the locations. We have 3 more sessions until 5:35, which is when we start our last session today, which is panel discussion. I'll be back here to say goodbye and for the close remarks, and then hopefully we'll have some swags to give away. I'm always excited about the swags. Okay, I guess now we are ready to start off the day. So let me introduce you to Mani, who is head of APAC Dev Ecosystem in Google Cloud. So without further ado, let me bring up Mani to the stage.
Thank you, May, and congratulations to GDG Singapore on 15 years. It's quite an achievement. 15 years is a long time. Was anyone around when the first event happened? It happened in August 2009 when Google was in the old office near Tanjong Pagar. Anybody? Okay, I guess I was the only lucky guy there. Thank you. I lead our team across Asia Pacific. We work with developers to ensure that, hey, Google is there to support developers as you all build on our platforms. DevFest, this particular event, over 600 events are happening worldwide just in this or next month. So it's kind of a worldwide phenomenon here. It's just not something that's happening just in Singapore, but pretty much wherever city you go to, there is a Google developer group which is hosting a DevFest. Let's go here. You all know that AI is a biggest opportunity in front of us. It is not something in the future. It is actually today, right in front of us. As developers, what are we doing is the open question that I have, is the open question that we are all thinking about. But just take a minute to think about how the world will look like 3 to 5 years from now. From what we see, AI is transforming variety of industries from healthcare to education to day-to-day office work to transportation. And not just industries, it is also transforming every business function, be it improving productivity of the worker, getting better insights and making better decisions about customers, or even in your direct product lifecycle and development. AI is already paving waves into this. The question for us to think about is, how as engineers, how can we empower all of you to build great products, to build whatever new tools for your businesses, and importantly, build a future on top of them, right? Here is one example, one that we are proud of, that, hey, a couple of Nobel Prize winners are now are employees of Google. But importantly, chemistry, which is a very disconnected field to computer science, the Nobel Prize winners in chemistry are proper computer scientists. Of course, Demis has a background in neurosciences, but you see that an AI engineer building a model for healthcare and medicine has now become a breakthrough. And today, AlphaFold, one of the models built by DeepMind, is accelerating drug discovery to such an extent that we feel that we are much more closer to curing some of the most difficult diseases that we never thought we could. Right? So drug discovery, and especially this model, is much better at predicting protein sequences, which has been a mystery to science for all of mankind. But now we are at least few steps ahead. So that is the level of impact AI has, and that's why Google in particular is very bullish on generative AI as a field, and we are continuing to invest. Our organization, we at Google for Developers, we think for software developers, AI is going to play an important role in 3 different segments. One, it's going to transform workflows. What does that mean? If you're building a front-end app, your UI can now be creatively done by AI. If you're testing applications, again, in order to test across a wide range of human inputs, how big range of devices, you can again use AI to accelerate your time from idea to deployment. Second thing, productivity. We see AI working hand in hand with you in debugging, in testing out your code, and literally every single step so that you can be faster along the way. Third, we also think it's going to enable user delight in new ways. With AI, you can now solve bigger problems, newer problems, which perhaps was not possible few years ago. So with all these three things, our organization is investing into three fundamental things to help developers be much more, one, have more productivity, have more fun, and also do all this more safe, reliably, etc. First thing, we're investing into models, platforms, and then last would be tools. With respect, let's go through each of them. Models, of course, is our biggest investments. You may have watched some of the hands-on sessions or participated in of them. Gemini is our biggest multimodal AI model, which has a long context window through which you all perhaps got a taste of it in the morning. We have Gemma, which is a family of lightweight open source models that you can just take, adapt in case right off the shelf models like Gemini don't work for you. And then the last, we have Vertex AI, which is our solution to deploy all these things on the cloud. And of course, we have a variety of 100+ models that we are housing on Vertex AI. But here is the most fascinating thing. This model creation at Google is now happening at a tremendous speed, much faster than anything else in the past, like operating systems, etc. Like Android OS was launched at one point every 6 months. Guess how fastly we are deploying models? There is one model that we just deployed, 11.14, which is practically 10 days ago. But yesterday we deployed a new model, which is 11.21, and I still haven't got the times to update. So it's really happening at a weekly cadence. The speed at which we are refining our models and addressing feedback is tremendous. And this is again LMSys, which is the leaderboard, and we're very glad we are top of that. Second thing we're doing is democratizing AI across multiple computing platforms. We see that, hey, the biggest way that we can get AI in front of consumers is through the handsets and their day-to-day work. So through Android and through Chrome, you can now build apps using Gemini Nano, which helps you deploy apps on device even without a network connection, but also in scenarios where you cannot just transmit data easily around. So for private and confidential scenarios, you can use this. Right? But if you look at the bigger picture, we feel Google is a very unique position because we have expertise across the entire stack. All the way from building Tensor mobile chips, which are able to run AI on your phone, to the operating system, to the browser for you as application developers, but also on the cloud. So if you are thinking of deploying or creating new models, working on Gemini or on the Google stack is going to be making you more productive because you can deploy the same model across all these stacks. And we are aiming for closest compatibility as we can. Last thing is tools. If any of you are Android developers, you may, in the recent releases, you may have seen that we have integrated Gemini into Android Studio. So if you need some assistance, you can ask a question to Gemini, and Gemini will look at your code base, use its own intelligence, and help you debug issues. And this is already live, or has been live for a few months now. Here is another example inside Google Cloud. So this is inside BigQuery. So you have a huge data set, and if you're looking to query the data set, all you now have to do is write that query in English, and Gemini can help you write the SQL query. That's what is happening here. And then it can also help you create visualizations just purely from plain text English. Right? These are just two examples, but we're looking to bring support and AI assistance along every single step along the development journey. The last thing I wanted to talk to you about is, hundreds and thousands of companies that work with Google are always talking about, okay, how do I deploy AI in a very safe and reliable manner? And one of the biggest steps we have taken is this SIFE white paper that we have just released, so that you as a developer can be looking into your data model infrastructure to ensure that there is no model theft or there is no prompt injection that can accidentally happen, so that you can be reliably confident that when you're deploying a Gen AI application, it's quite safe. So that's something I hope you all look at. I don't want to take too much of your time because we also have a guest of honor here. But what I just want to leave you all with is the future is here. Generative AI has the opportunity to transform every part of life in the next 5 to 10 years. And you as engineers have the front row seat in making that possible. Whatever problem you are solving, AI can help you do that better and solve that problem sometimes more efficiently. So think how you can use AI, experiment a little. It's okay if you don't get everything 100% right, but know that this is a path that is going to lead on to something great. And with that, I'm going to invite Dee Scully, who is, the slides need to be refreshed, who is the CEO of Kaggle. He's a guest of honor who has just come on the plane and practically 1 hour ago, but we just got him to do a keynote here with us. Dee, you want to come over?
Hi. Thank you, Mani. I really appreciate it. Let's see, we got a clicker here. Hello, DevFest. It is absolutely magical to be with you here in Singapore. I lead Kaggle, and I've been at Google for 16 years now. When I've lived a couple of different lives within the Google ecosystem. For many years, I ran Google's ad click-through prediction stack, and this was at the time, back in 2010, 2011, what we thought of as the world's largest scale machine learning system. And when we look back now, scale has gotten bigger. This is actually one of the most important trends we've seen in machine learning and AI right now, is that over time, the amount of resources that we've been putting into these models has gotten larger and larger and larger, which leads me to a question, which is that if we are normal humans who do not have access to infinite scale resources, is there something we can do that's meaningful in this space? And I think it's worth thinking about what this means. Because if I go back to what machine learning looked like a long time ago, like, 3 years ago. Anybody worked in machine learning 3 years ago? Yeah, a couple folks back there. Does it feel like a long time ago? Yes, it does. Okay, so in the sort of what I would call classical machine learning lifecycle, we would go through a very well-developed set of steps. The first is that we would collect a massive amount of data. First step, always collect a lot of data, and then clean that data, really inspect that data, go through a lot of careful data preparation, maybe do feature transformations, things like this. Then we would train a model, often starting with the simplest model we possibly could, maybe starting with something like a random forest or a linear model, just to make sure that we weren't overcomplicating things. Increasing model complexity as our evaluations show that it was important, and then finally getting that model out to serving. So this is what we used to do back in the day. And I will submit to you that in the current world of generative AI, the life cycle is exactly flipped. Instead of starting by collecting a lot of data, and the simplest model we can think of, we start with no data at all, and the most complicated model we can find. Basically, we start with the biggest, most capable model we can, and we see if it just works. And a shockingly large percentage of the time, it does just work. It's kind of magical. If it doesn't just work out of the box, then we go ahead and we start to do some manual prompt engineering or things like this. If that doesn't work, then we go to automated prompt engineering or adding in RAG databases or other control flow loops or things like this. If that doesn't work, then we maybe find an open model that we can do fine-tuning on or do some LoRa fine-tuning or stuff like that. And if that doesn't work, then we start thinking about training a model from scratch. So the paradigm is exactly flipped. And this means that, in my opinion, the world of AI is actually dramatically more accessible now than it was 3 years ago. Because the first thing that we do takes basically no resources. And the amount of resources that are required for each of these steps goes up over time, goes up with these different pieces. But we get to exit this sort of step as soon as we get something that works well. And so with this, it's also not even necessarily the case that we have to be writing code. Back in the day, if I was creating a machine learning system, I would often write some TensorFlow code or some JAX code or something like this to make my system work well. In today's world, you can do really useful work with a web-based UI like AI Studio. You can't do everything, but you can do really, really useful work, including things like strong prompt engineering or adding in fine-tuning. And this is true not just for Google's own tools, using tools like LangChain or other stuff like this as well are also really, really important and useful. We'll say that the idea that you would need to train your own model from scratch is, of course, something that is no longer true at all. And open models like Gemma and Llama and other open models out in the world are providing an incredibly useful starting point that allow us all as developers to gain the benefit of having somebody else having collected massive amounts of training data and invested massive amount of computes to give us a starting point that is really, really useful for training. And somebody might say, well, maybe that's great, but it only works in English. And actually what we found is that these models are fantastically good for being fine-tuned to languages other than English as well. And anybody here cared about a language other than English sometimes? Maybe, yes? Yeah, so we noticed that it's really important that these models are able to be tuned for local use cases. Now, as somebody who leads Kaggle, I also want to make sure that we're promoting localization and internationalization in a broad way. So we have competitions running to help make sure that we're promoting fine-tuning for localization as well. Ideas like long context windows are also a way for us to really look at ways that people can influence model behavior without having to invest large amounts of resources. And for me, the most interesting question about long context window, first is, does it work at all? And the answer is, surprisingly, yes, it really does. But the second is that there's a question of when should I use it? Because as developers and as engineers, I want to know how best do I influence my model's behavior? Do I influence that best by putting data into a long context window, or by putting that same data into a RAG database, or using that same data for fine-tuning? And this is something that I don't think the world knows yet. I think the world needs to discover it, and I'm super excited that within Kaggle we're having a competition that allows the world to discover when these use cases are most appropriate. I also believe that evaluation is maybe the most important thing that we can do as developers for our systems. Has anybody ever tried evaluating a system that they're developing? Nobody at all? I get no hands here? Oh, come on, guys. So I get one shameful late hand at the back there. All right. So it turns out that evaluation of models is incredibly important because the output space of these models is nearly infinite. And so this means that if we want to do a good job of being engineers and developing our systems, we need to be able to do a good job of evaluating our models and our system level behavior. Now, some of this is manual effort. Some of this we want to have be automated. And so I'm really excited that we have this competition running right now for helping people develop autorator models based off of LM-SIS style data. Lastly, I care a lot about efficiency. Even though the amount of compute needed to get running is, in my argument, lower than it's ever been before, it's still important that we want to make AI run as efficiently as possible so that we can keep doing a good job for the world. And so that's why I'm really excited that we have an efficient AI competition running that's in collaboration with the chess championship that's running now. So if you're interested in chess or AI efficiency, please check this out. So the last thing I want to say is that this world of AI is one that's being discovered. It's one where when these models are trained, nobody knows what they are going to be good at. We have some hopes, we have some dreams, we maybe even have some expectations, but we don't know until they've been tested and discovered. And the use cases for these models are similarly, I think, not fully known. We know they're good at being chatbots. We know they're good at doing code completion. But I think that we all believe that there is a set of use cases for these models that we might think of as more AI native use cases that is coming, and nobody has a strong hold on that yet. And so for folks in this room, I really hope that each one of you feels that this is something that you can participate in and that your discoveries are as important as everybody else's. So with that, I will say thank you. It's great to be here. And I'll hand it back. Thanks so much.
Okay, thank you, Dee and Mani, for the fantastic opening keynote. Let me introduce you, before we introduce you to our first speaker, just one announcement that I forgot to mention earlier. So today we have 2 tracks running in parallel, one here in developer space, another one in Himalaya. So please feel free to hop in, hop out of the spaces. And one more thing, the sessions starting from now, the next 3 sessions will be live streamed on YouTube, which means you are also live streamed as audience. So please be noted. So up next, we have Violet Deng, who will be sharing an idea to impact AI for every developer. Violet is customer solutions consultant working in Google Cloud. Please welcome. Please give a big round of applause.
Okay, hi everyone. I guess I was assigned the toughest part of today, which is go right after the CEO of Kaggle. So I'll try to bring some nice story to you guys and hopefully show a little bit of things that Google have done with Gemini so that you can see that this is actually achievable by everyone. And let's get started on your journey from ideas to impact with AI. So this is the agenda. I think it will make sense as we go. But first, I want to talk a little bit about engineering with language models and a little bit about the story of me and of some other things that are related to engineering. So as Dee asked, has anybody here worked in AI and machine learning over 3 years ago? Because I did not. And when it first came out, I guess a bit earlier than 2024, it came a little bit like magic. It's large, we give it information, and it gives great answers. We had a lot of excitement, and I was very, very excited to be at Google at the time and jump right into what we have and how to do it. But after a while, it becomes harder and harder to have it do what I want it to do. It becomes more uneasy to know this is not really what I have been working with previously, and for the longest time, I couldn't know why. So I kept looking and one day I fumbled on a talk by mathematician Terence Tao. He was talking at the International Mathematics Olympia of half a year ago, and he had some words that really resonate with me, which is, I believe almost everyone in this room is either an engineer, developer, or something adjacent. And the tools that we have, the tools that we grew up with, that we learned, were basically computers. We give it the code that we want, we give it a question, and almost all the time it spits out the same type of example, the same answer. Now, when large language model is introduced, it introduces to our computer something slightly different, which is when we give it the same question, it doesn't necessarily give us the right, well, not the right, but the same answer every time. And so you have to approach it as a different type of tools that will solve a different set of problems. If you keep pumping it the same way that we've been doing, then you'll end up frustrated and having to handle a lot of different problems at the same time. And so at Google, we actually have had the chance to have been doing this for a very long time. We've adopted AI into all sorts of our product for a long time. As you can see, Google Lens, Google Maps, Gmail. One specific thing that I find very useful for myself is the taking picture part of Google Pixel. Now, I take horrible pictures, and the only thing that keeps me from having zero social media presence is the fact that Pixel automatically makes my picture look better. And so that is the skill that we've been working at, and we have been working at it continuously ever since large language model came out. As you can see, one of our more proud creations with language model has been Notebook LM. If you haven't tried it out, it's an AI-powered research tool where you give it a lot of information, and you can do all sorts of things with this information. You can talk to it, you can have it create audio overviews, you can have it create podcasts. So to me, I've been using it as a very cool learning tool. So at Google, we've had to learn a lot of things continuously. And this has been a great help for my side. But there are a lot of things that we do that are a little bit cooler and a little bit closer to us engineers here. So earlier this month, I believe, at the 1st of November, we actually, I hope everyone can see, I was promised a very big screen. We did something that is very cool and very close to myself, which is we announced that we use large language models to actually find and catch the first zero-day vulnerability in code fully with LLM. This was on a blog post. I think the link is below if you've not heard of it. And so as a student of cybersecurity every day, I went in and take a look. And a lot of information is actually public on the blog post, but I'll walk through it with you guys a little bit to see how we came to this. And for you guys to see that from a great idea to great impact is just a few small steps. So in cybersecurity, there are a few sorts of different types of vulnerabilities. There's one specific thing that came up a lot of the time that we have a team called Project Zero, which is tasked with finding 0 days everywhere in the world, and they came up with they came to an issue, which is sometimes when you find a 0-day vulnerability, and you reported it, it was solved, but a few months later, the same approach of vulnerability showed up somewhere else. And for researchers, this is quite frustrating because this is a problem that I solved. It kept coming up. And for us, we coined this term continued in the wild exploits. And so when we have the stronger tool of large language models, a few folks at Project Zero came to the few folks at Google DeepMind to come together and try to solve the idea of giving the model the exploit that we have found previously and try to have it find it all over the place to see if this pattern is recurring elsewhere. And that's where we come to this. This is the vulnerability is a Stack Overflow vulnerability. It's quite simple. So one of the Sentinel value is not properly checked within the code. And so this type of vulnerability is very well known, specifically in SQL. And the first one, they run it through AFL, which is a fuzzer. It doesn't really work that well. And so that's why we kind of approach it with a different LLM approach. And so it's quite an easy vulnerability to grasp. And a very, very similar vulnerability was actually found by the Project Zero team. And so the first step that they take is that, I need to talk a little bit about like how they structured it. I'm sorry. So in the morning, I guess you guys were in Tuya's session where he talked a bit about agents, crew AI, and that sort of thing. The approach that we have here is exactly that. We have an agent that plans the step of figuring out what could go wrong here. And it has a tool which runs a debugger. So the assistant figure out like which type of input could cause problems, could cause a crash. Then they have a debugger tool which will run that command against the system and see if things go wrong. So the first step that we take is actually have a diff between the previous version and the newer rollout version. So this specific vulnerability was in kind of an unreleased, but in a beta version of SQLite, which is, I believe, very, very widely used. But this specific vulnerability was not fully released at the time it was found and was fixed very quickly. And so at first we have the changelog, and they run the changelog through the model to plan to see if what has this changelog updated. So first it's analyze the CL and identifies some interesting point that might identify a vulnerability. So that's a normal workflow of a bug hunter. Now, after it identified some possible interesting points, it goes in and tries to dig deeper into those interests and see what can we do here. And as you know with LLM, it doesn't get it right all the time. Sometimes it runs into some specific issue, sometimes it needs a little guidances. And for this specific instances, it runs into an issue of it kind of misses a library, and it kind of needs to add that tool in. But through the assistant, it actually identifies through the error code that was sent to it that, okay, I think I'm missing something. If I update it, then probably this will run again. And so automatically, it identifies where it goes wrong. It updates the commands that it needs. It adds a library that it requires. And after stuff, it actually finds the correct module. It correctly runs the commands that it needed. So that's one very, very cool findings that the team found, and one of the capabilities that can keep it running. So after a few steps, which is a little bit omitted, the model came to the specific interesting part that we showed at first. It says that, okay, the relevant column could have some issue here, and I will try to populate it with specific inputs that might make this go wrong. And it actually did. And so it actually came up with a command that crashed the program. After program crash, actually, it came with, it understands, it became a little bit smarter in explaining what happened, and it comes up with quite a reportable version of the failure already. And so it only needs a little bit of cleaning up before it's ready for a report to the SQLite team. Oops. And so this looks like it's very, very fun. It looks like it's very, very interesting. It came from a very, very specific idea of scaling the capabilities of finding out things that we already found, and we kind of don't want to waste our effort doing it again. And it came to great success. And the team's actively building more and more capabilities and doing a lot more things. But underlying the approach to what we're doing here is very simple. We have an agent that does a planning, that does the figuring out what we need to do, and we have a tool that makes it run against our system. And so from an idea to a very, very impactful result is only a few steps, mostly prompt engineering, nothing to do with the models. The underlying model that they use is the version of Gemini 1.5 Pro that everyone have access today through Vertex AI. And so that's where I kind of segue to some of the tools that we have that could help you on your journey to make some of your ideas to be a reality and bring impact with it. So as I think Dee already mentioned, we are very heavily invested on model development. So we have newer versions of Gemini Flash and Gemini Pro. We have a very, very long context window. We believe in context window helping everyone bring more valuable results to us. One more interesting thing specifically for use cases when we want our live application to run is multi-model streaming API. You can have streaming input and streaming output for multi-model and a very, very long context window. Another thing that will help alleviate a lot of the quota issue that we're running into, 4.29 errors that are fired out, is dynamic shared quota, so that previously sometimes we had to request more and more quota if our workload scales up. Now with dynamic shared quota, we kind of don't need to do this anymore and go straight to production. And Chirp is also one very, very interesting model. It's a managed speech model, which is kind of added to Notebook LM as well. It's the part that generates the dialogue. It's the part that generates the talk show that it does. And that was from the model development side. From the model builder side, it gives the users more capabilities in handling our model. We can distill it into a smaller version. We can tune it to our specific tasks. And we have very, very cool stuff, which is sometimes not all prompts will work with all models in the same way. So a prompt optimizer you can take your previous prompt, add it to the optimizer, and it'll pump out a version that works quite well for the specific version of the model that you're using. Another thing that comes into the part that Dee mentioned, which is evaluation. Evaluation is extremely important in generative AI, as generative AI by nature is a little bit chaotic. And in order for it to work the way we want, we have to have a way to do verifiable outputs. And so evaluation service kind of gives us an idea that we can guide what we do towards the result that we want. Control generation also adds into that point, where we can specifically structure the output in a specific way according to our data requirements. And Imagen is our state-of-the-art image generation model that helps us in creating even with words in the picture, and with great customization and editing capabilities. And the third part, which is definitely more close to what everyone does, is the fact the part that we will help you guys include your own data within the applications, within the interaction with generative models. Since the output is unpredictable at first, the things that we need to do is actually give the model the information that it needs to make a very, very well-educated guess. And this could be done through multiple different ways. We have grounding with search data, which adds the layer of Google search within the query itself, where you can route it on the most up-to-date information through Google search. We have multimodal function calling, which helps us in creating tools that will send API requests to our backend services and get the data that we need to populate the model with. Vertex AI Search is kind of our out-of-the-box RAG tool that we provide for companies and for teams to populate the model with their information very, very quickly. Document AI is where we can help, which does a lot of OCR, handling a lot of getting information from your physical documentation to data that we can use. And so grounding is one of the more important part about interacting with generative AI model. As I said, we can do it with Google Search, we can do it with third-party data through different connections, and the more important part is your own data through Vertex AI Search. Yeah. So I'll go a little bit deeper in grounding with Google Search, since this might be interesting to everyone. There is an option that's built in directly to the Gemini API where you can enable it, and you can have, and the model answer will have information from the specific Google search, and it'll provide a source link within the answer itself. So this isn't a separate API that you need to call and add in to make a different call. This is embedded and built into the Gemini API call itself. Another very, very interesting point, which is function calling. So you have your backend system. Your backend system is interacted generally through an API call. And an API call generally has a structure that you would like it to follow. So function calling gives the model the ability to get information from what it's sent in, populate the API call structure that we give it, and have a fully functioning API that we can call our endpoint and get the response, add to the model, and have it generate an answer that we want. That is based on the information that was given and based on the API data within our backend. And at Google, we can't stop talking about Code Assist. Also, about a month ago, Sundar, our CEO, also said that within Google, about 25% of our code is generated by AI as of now. And as what I said before, we have a lot of interesting approaches to it. And that's where we come with Gemini Code Assist. Now, one very specifically strong thing about Code Assist is tied into what Dee also said earlier. So this might not have been the worst part that I can have, which is a long context window helps the model be able to comprehend a larger corpus of data, which our code base probably is. And that's where we see our models grow as well. That's where we have had a lot of development and investment in to bring the capability of comprehending a large context. Now, my talk today has been a little bit less technical, a little bit less hands-on. So I'll give you guys something to go away with, which is kind of a starter pack that we have. On GitHub, the link is a little bit small, but on GitHub, we have a starter pack of having all the tools that you need to go from your ideas to a production level of application, which includes a lot of small stuff, which is an API server where you can serve the code itself, a UI playground so you can test your chains, you can test your prompts, your RAGs, a fully functioning CI/CD pipeline so that when you update a different version, it can directly pump into your running cluster. Ready-to-use AI patterns. So as you said before, as I've mentioned before, we use an agentic framework with a planner and a tool. And within this starter pack, we already have a scaffold of following that framework within a notebook that you guys can follow. Create your own tools, create your own assistant planner, and customize it to your will. And last but not least, observability, that we can add some more monitoring capabilities, not only to our system, but to our application running within the system as well. And I guess that will be it for me today. Thank you guys for joining. Hopefully you guys will have more and more fun sessions in the afternoon today. Thank you guys for your time.
Thank you, Violet. Up next, we have Jairaj, who's lead architect for data analytics at Google. Today, he'll be sharing the next generation of data architecture, AI Lakehouse. Please give a round of applause.
Good afternoon, everyone. I am Jairaj Bhuminathan. I'm a lead architect at Google Cloud, and I'm really excited to be here today to talk to you about the next generation of data architecture, which is nothing but the AI Lakehouse. Let's delve in. We are at a pivotal moment in terms of data and AI landscape today. wherein we are going to see how AI Lakehouse is revolutionizing the way we kind of handle and leverage the data. AI is rapidly evolving from the traditional realm of analysis into the realm of creation. We would see the convergence of prediction and classification into content generation, and the data platform that lies underneath will have some challenges in doing so. With the advent of generative AI, the traditional lakehouse that you use will have some challenges, and we will see how AI Lakehouse can handle that. In this, you will see there are over the past couple of decades, you would have seen two separate paradigms. One is the data warehouse, which you would have heard it more often. It handles more of a structured data and SQL-based analysis. And you would have heard about the term about data lake, wherein you handle unstructured and semi-structured data via programmatic access. With the with the advent of generative AI, you have to handle both of these, and there are excuse me, there are ways where you wanted to leverage the capabilities of these both. And this is where AI Lakehouse comes into picture, which is the next generation of next iteration of your data platforms. It typically offers a tight integration with the generative AI on top of your existing data platform. And when we talk about AI Lakehouse, like I mentioned, the generative AI is generating unique set of requirements, like handling the vast amounts of unstructured data like text, audios, and even images. When we talk about the traditional data warehouse, wherein you handle structured data, but with Lakehouse or with the data lakes, you will be handling semi-structured and unstructured data. But with generative AI, you have to handle some sort of unstructured data, like let's say audio recordings or even images and videos. Let's take an imaginary ride-hailing app. I'm just going to use a context so that you could connect with it. Let's imagine that you have an imaginary ride-hailing app, and the app could be named as Rideshare or whatever. For you to be able to do a quantitative analysis, which means when you are trying to do quantitative analysis, it's about how many rides have happened, how many customers have taken those rides, and what's the average cost for each ride, and what's the average distance. These are quantitative data. How about the qualitative data? When I say qualitative data, whether a passenger likes a quieter, cleaner car, or a driver likes has some preferences for his own car, how do you match the customer or driver preferences? And that's more of trying to identify the qualitative information. But where do those information comes from? Let's assume you are excuse me, your customers are calling up the contact center, and they are just giving reviews, or they are writing reviews in social media. The likes of it could be Twitter, it could be any of the social media handle. You've got some sort of quality information out there, whether that customer likes it, or which is like a positive, or it's a negative review, or it's a neutral review. And the same goes for there is always a two side of the story, and the same goes for even driver. What sort of preference does he has? So where do we have these? These are basically qualitative data, and doing this is not that easy as we speak. Being able to do a quantitative analysis is a lot easier, but being able to generate a qualitative theme, like what sort of preferences does the customer have? And today we'll be looking at how AI Lakehouse is at the forefront of this revolution, wherein it allows you to handle this qualitative analysis at ease by leveraging the LLMs. Excuse me. So like I mentioned, what does AI Lakehouse brings in as a capability? When we talk about unstructured data, you would have heard about they are mostly stored in an object storage. But how will I be able to see that in a structured way, or will I be able to use a SQL query on top of them? So we've got something called as object tables, and you would have heard something about vector embeddings. So you need a vector embedding store, like wherein you store those embeddings on a database, which can be queried at a lower latency, right? So these are some of the capabilities that the AI Lakehouse brings in when you want to handle the unstructured data or even semi-structured data. This is let's kind of quickly take a look into the traditional data lakehouse architecture, which I'm sure you would have seen these slides many a times, but I want to kind of delve into the different layers, and so that you understand what does an AI lakehouse look, how does an AI lakehouse looks like. You could see that it has a data storage layer, data ingestion layer, and when it comes to data processing layer, data governance, and data consumption layer. And when we talk about data storage, you do see lots of storage options in terms of being able to store your structured data or your in BigQuery managed storage, or it could be your uh, structured data in terms of Parquet, Avro, or ORC files, which you will just store it in an object storage to the likes of Google Cloud Storage or AWS S3 or Azure ADLS V2, right? So these are the storage options that you do have, and that's what you see over here. And when we talk about handling different types of ingestions, you do have different types of ingestion options in terms of doing the streaming and batch ingestion. And we do have services around that. So in order for you to handle real-time streaming data, we've got PubSub and Dataflow, which is a stream processing engine, unified stream and batch processing engine. And if you're trying to do some sort of change data record, change data capture, we've got something called as data stream, which can be used to do the CDC. Likewise, we've got other services with respect to data ingestion. The same goes with, hey, now I have the data with me. What do I do with it? What do I, when we talk about processing, you would have heard this. People might be using a lot of processing engine. So you would have heard the term like ETL or ELT, which is like extract, transform, and load, and extract, load, and transform. So what does it really mean? It really means that the ability to be able to do the transformation logic. If the transformation is logic is within the SQL realm, then you could use BigQuery. Or if you're already using your transformation logic with some of the open source engines like Spark or Presto, then you could use something like Dataproc. So it really depends on where does the transformation happen. Does the transformation happen within the data warehouse or the lake house that we talk about, or does it happen outside of it? So that determines whether you follow an ETL or an ELT flow. And that's what you see to your right. These are the data processing services. And to your left, that's where you see data governance. When we talk about data governance, it's about data lineage, data security, data profiling, and all of those sorts of capabilities. And that's provided by a service named as Dataplex. And you would see observability, which is a function, and that's within the ops suite that has like data logging, monitoring, and alerting. And all of this can be orchestrated through something like an open source Apache Airflow, right? You would love to orchestrate this through an open source service. Then we have a managed service for that, and that's called as the Cloud Composer. And within BigQuery, we've also got Dataform, which can do this. Likewise, when we talk about storage, governance, data ingestion, and processing layer, we obviously have data consumption layer, which is more around being able to consume the data. Whether you are a business or a data analyst, you will be consuming that through BI tools, to the likes of Looker Studio and Looker. Those are two different BI tools that we have. And of course, with the it's more popular with the data scientists and ML engineers or ML ops guys, is the Vertex AI, which is our unified AI service. And this is more of giving you a very high level intro into what does a traditional lakehouse architecture looks like. So what do we mean by AI lakehouse, and what does it really bring in? Excuse me. So when we talk about AI Lakehouse, it does bring in the assisted AI development. We are talking about leveraging Gemini, or it could be any other LLM, but in the case of Google Cloud, it's Gemini. So when we talk about assisted AI development, we do have Gemini capabilities within most or all of our data products. Let's talk about Gemini in BigQuery, and I'll have a short demo if time permits. Which means you will be able to do a SQL code generation, or be it a Python code generation for your notebooks, or you will be able to do code explanation, or you will be able to even write a natural language and build a BI dashboard, or you will be able to even write a natural language and build a data canvas. So these are some of the assisted AI development capabilities that has to be there on top of your existing data platform. And that's what I meant by AI Lakehouse is the next iteration of your data platform. And of course, it has to support the new generative AI use cases. When we spoke about how AI is evolving, wherein, excuse me, wherein we talk about standard or a typical prediction and classification type of problems that you were trying to solve, but the Gen AI is bringing in new capabilities. It can generate content, it can understand data, it can understand natural language, right? So it does require some additional capabilities, and that's where Google is at the forefront, wherein Google Cloud's AI Lakehouse does provide you these capabilities. Let's kind of quickly take a look at the data lifecycle. I'm sure that some of you might have been familiar. If for those who are not familiar, let me just walk you through. So there are like two sides to it. So one is the data engineering, and one is the, when we talk about, data scientist and ML engineer. So when we talk about data engineering, the typical data life cycle, how it goes is like you would want to ingest your data into whatever lakehouse that you have. So when we talk about ingestion, once the data is ingested, you would want to prepare the data so that it can be consumed, or it can be ingested into data lakes and data warehouses. That's where the processing services, like whether the SQL transformation logic, you transform the data using SQL within BigQuery or using Spark or Presto. It could be anything, right? And then when we talk about moving the data into data lakes and data warehousing, then a key component comes in, which is cataloging, data cataloging. When you are managing data, you need to have both business and technical metadata. So only then you will be able to bring in any sort of governance. When we talk about governance, it's metadata-driven governance. Please keep that in mind. When anybody talks about data or AI governance, it's metadata-driven governance. If you do not have metadata about your data or your warehouses, your ML models, or your BI models, or any of those sorts, you need to have metadata, not just technical metadata, but also a business metadata. Who owns it? What problem does that solve? And you would need something like a data catalog. And once you've cataloged everything, the next important step that you typically would do is like you want to do EDA, exploratory data analysis or data exploration. And then you would want to wrangle the data and do data pre-processing and generate insights for experimentation. So what you see to your left, that's below these yellow bars, are mostly focused around data engineers and data analysts. And these are the tasks that they would do. But what about the key folks, right? AI and ML engineers. They do a couple of areas they do focus. That is model development and model ML deployment. So once a data insights has been generated and they've experimented with it, another key task that we need to focus on is feature engineering. I might have 100 columns within my databases. I might have 200,000 or 200 databases, which gets collated into a data lakes. But what are the key columns? Will this customer buy or not? That's a classification problem. What is going to be the weight of an X or weight or a baby that's X years old? So that's a prediction. Or how is it going? How we are going to do the let's say in Q4? What's going to be my sales numbers? So whether it is classification or a prediction, you need to be able to extract exactly the features, which means in a simpler terms, which columns that I'm trying to predict, right? I could use supervised or unsupervised ML, whichever models that I prefer, which means that feature engineering tasks happen. You need to be able to have a feature store. If you are a larger organization with 100 different business units, will every organization build their own feature store? You need to have a centralized feature store, which has a lower latency, and you want to be able to query that in a sub-millisecond. So that's where Vertex feature store comes into play. Once you have your feature, feature engineering done, and you've extracted the features, ideally, this is where you will build your models. Of course, you could choose the algorithm of your choice and a toolkit of your choice and start building your model. And once a model has been built, of course, you would want to kind of store that model somewhere. That's where model registry comes in. So that if one BU has solved a particular business problem, you don't want the other BUs to reinvent the wheel. So if a similar problem has already been solved, you will kind of leverage the model if it's the same org, right? So that's where model registry comes into picture. And of course, once a model has been built, you would want to do some sort of, what do you call it as, experiment tracking. You want to do some analysis. What is my F1 score? What is my AUC, ROC, right? You want to kind of do that experiments, right? Within Vertex, we have something called as Vertex experiments. For your kind information, Vertex AI is a service with more than 627 features as of yesterday. I don't know how many it is today. And I'm being very honest, being a Googler, you need to read a lot, right? So that's a feature provided from within Vertex. It's called Vertex Experiments. So now that you've experimented with your model, you would want to deploy that model. You deploy that model, be it whether it's a real-time prediction or a batch prediction, right? So when you want to do a real-time prediction, you need to be able to have an endpoint. So within Vertex, we have something called as Vertex endpoints, which both for batch and real-time predictions. And of course, you serve those models. You would also want to do a model monitoring. How did my model perform? Model A versus model B, right? So these are typical tasks. I'm sure one of it might have reflected into what you're already doing, but keep only two services in mind. Anything to do with data engineering, BigQuery, that's to your left. Anything to do with AI, we have a unified service, Vertex AI, the one with 627 plus features, and it keeps growing every day, right? So this is a typical life cycle of the data life cycle, which you need to keep in mind. And I was discussing about data governance. So when we spoke about governance, it's metadata-driven governance, which is to your left, provided by Dataplex. And orchestration, you can orchestrate this through, again, it depends on the ELT or ETL choice, whether it is Cloud Composer, Apache Airflow-based, or BigQuery Dataform, which is more like, DBX-based, right? DBT-based, apologies. Now, with the generative AI, it kind of blurs the personas, the borders between the personas. So let's take a quick look. Whether you are a business user or a data analyst or a developer or an AI practitioner or a data practitioner, a business user who was earlier depending on BI or a data analyst to be able to generate a report now has the capability to go ahead and type a natural language query and generate the BI report that he wants. Has he become a data analyst? No. Everyone is taking part. Likewise, you've had data engineers who used to depend on the ML engineers to be able to build a model and deploy that model. Now they can do that within BigQuery ML with a simple SQL statement. Has he become an ML engineer? No, he's still a data engineer, but he's trying to offer into the AI-powered innovation. So the borders between the personas are getting blurred. And my colleague, I think Violet and previous other colleagues, they were highlighting about code generation, right? We are talking about developers. They can directly consume any of the pre-trained API, like speech to text or text to speech, right? Or they would want to do video analysis or video intelligence. We can use any of those API, directly consume those API. So the border between these personas are getting changed, and your underlying data platform that we are talking about should have the capability to be able to support the GenAI use cases and provide the GenAI-powered assistance for all these personas. So how can everybody contribute in an organization to the AI-powered innovation? You go ahead and talk to any of the CXOs, and I keep interacting with them quite often, and everybody says, hey, we want to be an AI-powered organization. We want to be like Google. Okay, how do you do that? You wanted to kind of make it a team sport. So how do you make data and AI a team sport? Think about Vertex AI. It does have features it does have, pre-trained APIs like, the Vertex speech to text or any of the other APIs, natural language translation and other APIs, to a fully customizable, model development features or ML ops within the Vertex AI. So Vertex AI does provide all of these, be it a developer or be it a data engineer or be it an ML engineer or a data scientist, right? You need to make it a team sport. But how do you make it a team sport? You need to provide a unified workspace, and that's where BigQuery Studio comes into play. So it does have the feature wherein you can just go ahead and write SQL codes or generate SQL codes or even generate Spark codes for your PySpark codes or any of that for your notebooks. And you also have more features, which I'll be able to demo in, I think I do have some time, which is like more of building a data canvas. How about a data analyst? You've built an amazing data warehouse or an AI lakehouse, and your consumers does not know how to consume that. They don't know where to start. So we do have some solutions and cool features for that. For the users with a cold start problem, they can just simply be within BigQuery. We have something called as BigQuery Insights, and all of this is within BigQuery Studio. They can just simply go there and generate insights. It'll give you the top 25 queries to be able to run. It analyzes it. So we have embedded Gemini capabilities, which means LLM capabilities, into most or all of our data products. So that's one thing. And you've got data analysts of all experience. Let's say you've got an experienced data analyst who knows your data model in and out, which means he knows what features to select, what columns to select, and what tables to be joined, and what queries to be run. So you can just go ahead and build a nice data canvas. When you say data canvas, it's a visual data canvas. And using that can be passed on to the new data analysts who are joining, which means it's no more a tribal knowledge. With the power of the LLM, all of this can be done with a simple natural language. So BigQuery Studio, it'll help you to make it a team sport. Excuse me. And with the collaborative nature, everyone will be able to kind of contribute to the GenAI workflows. So now we've been talking about some of the cool features, or what does an AI lakehouse, what sort of what does an AI lakehouse look like. Now, kind of let's quickly delve into what does the next generation data architecture looks like. I was talking about, to fall back to what I was telling you, about a ride-share company wherein they wanted to do quantitative and qualitative analysis. So what does the architecture looks like? Think about, how many of you all know what is ETL or ELT? Or can somebody raise a hand? Okay, great, there are a few hands, right? So you would have heard about ETL is nothing but when you have data, you extract, transform, and load it into your data warehouse. Or with BigQuery, we always recommend ELT. You extract the data, load it, and undo the transformation. That's the only thing. So traditionally, the qualitative analysis has to be done using multiple steps. With the LLM, in this demo or in this particular architecture, I've used Palm as the LLM. So let's assume that imaginary ride-hailing company wherein every customer is calling, or even the driver can call and give a review, or it can be social media post. And all those files are stored, those are like unstructured data, like MP3 files, that's stored in let's say in a Google Cloud storage, and even the associated files, associated tables are stored in Parquet. That can be loaded into the raw zone, which is again, for unstructured data for like audio files, you will create them as an object tables. Using the LLM, in this case a Palm, you can leverage Gemini or any of the other LLMs. You use that LLM to kind of, and use Vertex speech to text, you kind of convert that into text. And from within that text, using Palm, you will go ahead and see what is the sentiment, the categorical data, whether it is positive. Driver was polite, he dropped me on time. So these are like positive keywords, right? You kind of, or maybe it could be the customer was rude, or maybe he was expecting a car that didn't have any smoke smell. There are customers who prefer a non-smoking car, right? So all of those categorical information can be fetched, and then it can be loaded into enriched zone. And from that categorical information, which is like qualitative data, you can build a customer or employer, or what we call as an employee or a driver profile based on the historical. We are talking about thousands and thousands of reviews and millions of reviews. I do know few ride-hailing companies, they leverage Gemini to do this in real time, right? To do this in real time, and it's happening in Southeast Asia, right? So once that is there, you will kind of generate a summary for every review, and then you want to use LLM to fix LLMs. Not everybody speaks the same language, right? When you generate the text to, audio to text, you kind of summarize that. You want to kind of fix the grammatical errors and build a nice summary and build a dashboard. And you combine that with your quantitative dashboard as well, or quantitative analysis. You will be able to see both quantitative and qualitative analysis data. So in this case, you are using LLMs, which be it Gemini or Palm. It can be used as an ETL processing engine. You would have heard about only generating content like text, audios, and videos, but you need to just think out of the box. You can use that as an ETL processing engine, and that can be part of your solution. It can extract text, and it can extract sentiment, and it can summarize, and it can also do other sorts of analysis because it understands language better, and LLMs are getting better and better every minute, not every day, right? So let's quickly take a look at the demo. I think I have got 5 minutes. I'll walk you through. These are summary of customer reviews, and I'm going to just click at the customer profile page, which means it has the combination of both qualitative and quantitative data. So this is for example, I've chosen a customer name as like Nicholas Hawkins. It says the customer's preference is for a cooler vehicle interior, and they like the driver who drives fast and does not talk, right? These are all preferences. These are all qualitative data that lies within the audio recordings, right? And they also prefer a clean car with the radio off. Okay, makes sense, right? Customer review metrics, it says like he has written 36 number of reviews, and 14 of them are positive, 18 are negative, and 4 are neutral. And there is a generated summary for the customer reviews. It spans across multiple drivers. Likewise, and there is also the customer trip metrics, which is more of a quantitative data. So total number of trips that he has taken is like 4,210. I don't know where he drives every day, right? And average number of riders and average trip distance, fare amount, and these are all quantitative data. So all of this is done through the architecture that I was referring to, right? You kind of extract the audio file, convert it into text, extract sentiment, and then load it, and then generate summary, and then provide that for the holistic organization. Now the same goes for how there is always a two side of the story, right? One is a customer. Let's talk about drivers or employees. In this case, this is the particular driver. His name is like Vinicio Jordan. He keeps the car too warm inside. They like the radio on and don't talk to passengers. And he has some reviews about customers, right? So that his manager understands what sort of persona he is, or the tool understands what sort of persona he is and matches that with the right customer and the right driver. And this is the LLM generated summary for the customer reviews. And he's got an average number of, let's say 1.32 passengers, and the average fare amount is like $12.06, and average total amount is like $14.so. So these are powered through LLMs. And you imagine you could use Gemini, you could use Palm, you could use any of those LLMs, but think of that LLMs can also be used as an ETL processing engine, not just to generate audio, video, code, right? And even music nowadays. And let's kind of, let's look at the architecture. Let me quickly show you while this is just a tip of iceberg, I may not be able to show all the features that I was explaining. So this is something called as like data canvas within BigQuery Studio, targeted at those data analysts, a senior analyst who could just build, right, a visual canvas. He can just select the tables and then just click join and give a natural language saying that write a query, which is like get top 10 customers. It automatically generates a query to get the top 10 customers. And next he can say, from that results, it's basically querying the query results, right? Which is like extract the top 10 customers with the most review. That's the query it generates. And those are the customers. You can just simply go ahead and type, create a bar chart. I think bar chart using green color, or you can even change that to whatever color that you want. All of this is powered through natural language and of course through Gemini, right? This is for those users. This is more for a visual data canvas, and we've got data prep. Apart from the standard SQL query generation, code explanation, or Python code generation, this is targeted at business users and data analysts. So there are more features. I think I'm a little bit running out of time. Let me see if I could show you the data insights. And all of that I spoke about, it's just a Jupyter notebook, right? All of that, it's just a simple single notebook. For those who love Python, you can just simply, you can see that the first key step is to review speech to text. I just simply write some code. And then I was just running through when I came here like a couple of hours ago. And then you will be able to review the sentiment. Basically, I want to kind of know whether it is positive, negative, or neutral. And this section of the code will help you. Then you extract the theme from those customer reviews. And all of these are done through LLMs. I'm not using any other tool. And I'm just writing a simple code. That's basically getting a driver and customer theme extraction. You extract the theme out of it. And from that theme, you will be able to summarize all the reviews. And the next step is to use LLMs to fix LLMs. Basically, fixing grammatical errors and all, or even commas and apostrophes within those reviews. And then perform a quantitative analysis. So all of this can be done through a simple notebook. Like I mentioned, it's a limited 30-minute session. The capabilities are unlimited. But again, this is what an AI lakehouse looks like. And I hope this session has given you some insights into what an AI lakehouse is. Thank you, everyone.
Thank you so much, Yaraj. It was really practical and full of insights. So, okay. Can someone help me with the screen, please? Okay, up next we have Wei Yuan. I think many of you have seen him before with this red cap, which is his trademark. Wei Yuan is Senior Engineering Manager at Ascenda as well as Cloud GDE. Today he'll be sharing build your own search experience with Google Cloud with Vertex AI Studio and Vertex AI Agent Builder. Off to you, Wei Yuan.
Thank you, May. All right, so thanks for staying behind as well. I can see a healthy stream of people that just left, and I mentioned to the organizers, wow, stress, so many people leaving. But thanks for staying behind. I'm jesting here. Thanks for staying behind in, going through this sharing that I have over here as well. And through this sharing today, I want to share with you certain Vertex AI tools that will help you in being able to empower you to make your own Vertex AI, Gen AI powered applications. Okay, and I'm coming in from the perspective of a application builder. All right, so yeah, as mentioned, I'm an application builder. I've worked on front end, back end, DevOps, and I find a lot of pride in doing this. Building good UX, good products for users to enjoy. Okay, and as an application developer, right? I like to say that it's not like a very simple thing where you build features, you deploy it, and then your users get to use it. Of course, there's also the part of building it as well, right? And sometimes your product manager come up to you and say, "Hey, can you build in XX feature?" Like for example, can you build in a product like search? Okay, and then you start looking around online on Google and see, how do I build this thing? And usually you end up with many different options on how to build this product that you want. Okay, so today I will walk through some of the Vertex AI products in Google Cloud in a way, right, to show you how you can use that to build a search experience using Google Cloud, and at the same time introduce to you how you can use these tools for you, when you're using to build your own products. So we'll start off first with Vertex AI Agent Builder, which is the yellow one on the most left. All right. So this is what I will consider as the low or no code solution. Okay, so if you're using Vertex AI Agent Builder, right? Some of you who have joined our conference, I think like maybe 1 month ago, sometime in September, you guys might have used this, and we actually went through the agent option. But today I'm going to be looking more towards the search option. Okay, and when you're using Vertex AI Agent Builder today, you are greeted with these 4 options. So if you are using it to build your own search engine, this is maintained by Google themselves, who has perfected their own search engine, right? And you're sort of using their same technology, that's used to power this search engine product, right? To create your own search engine. Okay, so to create that, you just need to click this search button or this select button, okay, and then provide some sort of data store to be able to back, what needs to be searched from this search engine. Okay, and essentially you should be able to create your own search engine in 15 minutes or less. Okay, so let me kind of show you how we can do that in an actual scenario. Okay, so let's say, okay, if you go to Vertex AI Agent Builder, you will see something like this. Okay, of course, you won't get the same thing that you see over here because I already use it to create a few applications. You can see I created 2 apps, but you'll definitely see this create app button. Okay, so like I said, you can create an app in your search engine in less than 15 minutes and even being able to integrate within your site. Okay, and it's very simple. All you need to do is click this create app button. Okay, as mentioned, you'll be greeted with the 4 options that I mentioned just now. Did they add more? I guess they did add more. Oh, changed a bit already. I guess something got released over the last few days. Icons also look actually kind of different now. Okay, anyway, demo usually not going to plan exactly, but because maybe they just released something in the recent last day. But the option search is still there. Okay, so I'm going to go with the basic option. I don't really want the enterprise options. Okay, and so I'll disable that. And then let's say, I'll just add some random names over here because I'm not really creating this for you. Okay, and once you set that setting in, you indicate that you want to create your own search experience here. What you need to indicate to the agent builder now, right, is that you need to put some sort of data store behind. Okay, so of course, these options over here are data stores already created, before this session. You won't have this, if let's say you're using it for the first time. So you have to click the Create Data Store button, and you'll see that there's a multitude of different options you can use. Especially if you're already in Google Cloud, maybe you have your own web application using a database service like, let's say, Cloud SQL or AlloDB. You can actually implant those, right, as data sources for your search engine. Okay, or if let's say you want something maybe simpler like cloud storage, you're putting like some JSON files in some bucket, right? You can do that as well. Okay, and that's what I'm going to be doing here. So let's say I'm using cloud storage, and maybe I'll indicate a structured data file. Okay, indicate let's say like some file over here, and I believe I do have. Let me see over here. You can see some of these JSON files that I've already created before. Okay, I'm not going to create it for real, but these are the files I've used before to create the data stores. Okay, and if you click continue, they'll create that data store that can be used in your search engine. Okay, so by clicking continue, you should get one of these two options lah. And then you can select the right data store and click create. Okay, and this, after you wait for a couple more minutes, you should get to the created application that you can already use and sort of test it like for that search experience. Okay, so let me show you what I mean by, in less than 15 minutes, you can get that entire search, no code and search results from there. So let's say I click this option, right, one of these apps I created where I link it to 2 different data stores. Okay, you can see here that they already give you sort of a preview that's linked to that, the information that I link, the data store that I link as part of this application. And let's say I search for a Pixel phone because I link a Pixel phone data set here. So I search for Pixel. Okay, and it should generate or at least give me the results that is within that data store that I was able to implant as part of this app creation. Okay, so this already shows you a very quick way on how you can get started. Okay, but this is not exactly integration. If you're curious on integration, you can click the integration button. They actually will give you like some snippet. Okay, let me make this a bit bigger. They give you some front-end snippet to be able to integrate as part of your website. Okay, so by doing this, again, you already have like a Google-grade, production-grade search experience in your website just by clicking a few buttons, like I say, in less than 15 minutes. Okay, but some of you at this point might be asking, that doesn't feel very secure. Do I just want to just embed this widget on the front end, like sort of, there's some token over there that probably is exposed, right? Everyone can use it. What if I want to maybe put like some sort of backend integration instead? Maybe wrap it behind some API endpoint. And you can do that as well. How you do that is you can essentially make use of the, what's that? Let me show you over here. You can, okay, never mind. Let me just go to the next slide. You can use the, the SDK itself, the right SDK itself, Discovery Engine SDK, to link it to the Vertex AI app that you created. Okay, they'll give you the right configuration that you can link to this SDK itself. And in less than 70 lines of code, you should be able to service your own API endpoint and return that same results, the one that I just showed you, within the sort of the front end way of doing it. Okay, but in this case, right, you're actually wrapping the results in a backend API instead. Okay, so over here, I'm also trying to stretch it, putting in like more query parameters like per page or page, because I kind of want to sort of boost up this search API behavior. You don't just want it to be something where you just put in a search term and return results. You also want to make it a little bit more customizable. Okay, and all that just took 70 lines of code. It's very much low code. Like the moment you create this app on the Vertex AI Agent Builder, right, you should be able to get to this really quickly. Okay, I know this one is kind of small, and that's the point of it. Like it's just to show you the skill over here that you can just create this very quickly. Later on, I will share some of the code that I wrote if you want to reference this later, like to do this yourself as well. Okay, and essentially that's it. To create your own search product using Google Cloud's Vertex AI tools, right? For example, in this case, Vertex AI Agent Builder, just like that, as an application builder, with a few clicks of a button, maybe integrate a bit more code, you get your search experience right away, on top of your fingertips. Okay, so with that, we already covered away one option. So let's now explore the other options that you can use to create your search product using Vertex AI tools in Google Cloud. So the next one we're going to be looking at is the reasoning engine. Okay, so reasoning engine it's somewhat touted as the managed runtime for LangChain. Some of you might know that. I'll explain what that is a bit later on. Okay, so going into reasoning engine, one disclaimer first, note that this is still in preview, so please use it for, I guess, for testing purposes. For example, if you are already, let's say your company is using something like LangChain, you can use this as a way to deploy your workloads, sort of as a serverless for Google Cloud, but don't use it in production yet because it's still in preview. Until it goes into GA, at least wait for that. Okay, so what exactly is reasoning engine? The definition of it essentially is that it's a managed runtime for frameworks like LangChain, which are model orchestration frameworks. Okay, you don't exactly use it to host your models, but more so to interact with it. Okay, and you can use this within Google Cloud. Okay, so it's more of a deployed runtime solution, and if it's not just for running Google-related models, you should be able, or at least what they are dictating in their documentation, other models like you're integrating to in the future as well through reasoning engine, that you can deploy sort of like in a serverless way in Google Cloud. Okay, and just to show you, if you look at the template code inside reasoning engine, right, on how you integrate it, they actually direct you to use this reasoning engine SDK. So it's kind of like, you might think, isn't this like a bit like vendor locking yourself? But actually, they will run through the code and let you know that, hey, you know, the equivalent of this, this is how it looks like using the LangChain Vertex AI module. Okay, so in fact, you can just you should be able to replace with this code, use this to create an agent, deploy using the reasoning engine SDK, sort of as a serverless instance in Google Cloud, and you should still work, you know, like in this case, creating your own search experience, having that search instance being deployed in Google Cloud for your use case. You can use it exactly the same way as well. Okay, and the integration code over here. So if you look in deeper towards the code I recreated using the reasoning engine SDK, right? One interesting thing over here is that you'll see that there's a reference towards this Vertex AI, this function over here, or rather, sorry, I'm going a little bit further ahead of myself. There's this reference over here to Vertex AI query. So what does this exactly mean? So in the code base I'll share with you later on, right, you actually see that this is a reference to a function that's written over here. And this function actually dictates how I create this search behavior inside reasoning engine as an agent. Okay, but one interesting thing is that you'll see that it's actually calling this serverless, there's this GCP Python serverless URL. So this actually is integrated back to some Cloud Run function that I'm using, okay? And the very interesting thing here is that actually it goes back to the earlier solution that I showed you, the Vertex AI Agent Builder, right? Where just now I think I accidentally skipped this slide. But what I meant to show from here is that in this code that I showed you just now, how you use the backend code to be able to wrap around the Vertex AI app that you create using the Agent Builder, I then host it using Cloud Run in Google Cloud, sort of as a serverless instance, okay? And then you have like some sort of URL over here that you can use. And then what I'm doing is, in Reasoning Engine, as the AI agent, I use it to wrap around this, this app that I created, okay? Sort of trying to just reuse the functionality that Google has already built, rather than trying to reinvent or try to recreate search, okay? And there's a good reason why am I doing that. You know, as mentioned, right, Google already has created sort of this production-grade search experience. There's no point that I try to sort of create that logic myself as well. But rather, what I want to do is to use Reasoning Engine to wrap around it and build a much more customized experience, okay? So customized experience, I'll mention about, like, I'll dig in deeper into that in a little bit. But what's used over here essentially is this concept called function calling to wrap around this tool, this Vertex AI agent app that I created. Okay, and what I mean by customized experience is that just now we talked about using the Vertex AI Agent Builder to build a search experience. Okay, you can put it in the front end, you can put it in the back end, you can write some code and wrap around it. Okay, but by using Reasoning Engine, we want to add in more functionality. Let's say this search engine is used in Shopee. You know, you can use it to search for a multitude of different products. But all you can do is just do search with it. You can just search for products. But what if, let's say, you know, as a developer, I want to add in a bit more oomph to it. Let's say it's for global users, and some people want to convert the cost of a product they search into a different currency. So over here, you can see that I can actually insert in multiple different tools, like, you know, on top of this Vertex AI query, right, I can add in additional things on top of it to let reasoning engine know that, okay, in particular cases, users might not just be asking about searching for a product. Maybe they're asking about, can I convert the cost of this product A into another currency? Okay, so through this reasoning engine, right, let's say if the model I'm using is Gemini, right, like over here is using Gemini, the model itself would pass that prompt and they will know that, hey, I should be passing the user to this exchange rate query if the user is not doing sort of that regular search. So this makes your search experience a lot more personalized by using this concept, function calling, which allows your model over here to understand, you know, not just simplistic search results, but also how can I get very customized search results for certain users who want to find a different thing, for example. Okay, and not just, of course, doing exchange rate, you can also add in things like, for example, over here, I put in a Wikipedia query as well. In my demo later on, I'll show you like how this function calling, like maybe I'll just put a search prompt in, right? And you'll see that you'll come out with different results every single time. Or different results as in different results to different prompts, showing you that this function calling, right, allows you to direct different types of search to different results, giving you that customized experience. Okay, so deploying using reasoning engine, just to mention that because this is still something that's in preview, everything has to be done in code. Surprisingly, like I think some of you who are used to as application developers, right? You write code, you think that most of it is a little bit stateless, right? You're not really saving it to a database. But the funny thing is, like, if you run this code, right? Okay, let me go to the next slide. You run this code where you call reasoning engine.create with some agent that's defined here, right? Actually, you will create that serverless instance in Google Cloud. So just to mention that today, because I guess it's still in preview, they haven't really moved, they haven't really created the web version of it, web console ways to govern your reasoning engine instances. So just to note that this, if you run this code, right, make sure you also periodically check to see if you have these instances running up because they cost money as well. And make sure you remove them if you don't want to test it anymore. Okay, and then in terms of after you deploy it, in order to interact with it, to query with it, right, you can just do something like this, like you are using the SDK, you pass the resource ID that's returned after you create it, okay, and then you just create an instance of that, remote instance of the application and pass in a query in, okay, and you should get the results, sort of like, you know, how you interact with, let's say like the Gemini, right, you know, when you put in chat message, they come out something directly from there. Okay, and with that, we have sort of covered the second option of how you can use Vertex AI tools in Google Cloud to build a customized search experience. Okay, so earlier on we talked about Vertex AI Agent Builder building a Google production grade, you know, search experience by just clicking a few buttons. Going to reasoning engine, you get a deployment option, and you also get a sort of this library that you can do function calling, allowing you to inject more customized use cases within this search product. Now, let's go into the last one, which is the center option over there, Vertex AI SDK, which is something you can use to also build this search product as well. Okay, and I have one confession over here, which is that reasoning engine use and Vertex AI SDK use is exactly the same, or actually not exactly the same. Most of it is the same, but I'll talk more about the differences then, you know, why you might choose maybe an option like reasoning engine over Vertex AI SDK or vice versa. So like reasoning engine itself, of course, you get options like, for example, if a company is already using something like LangChain, you can deploy using that option. But if you haven't really selected any options, actually, you want to use Gemini, right? You can actually use the Vertex AI SDK, which could be a better choice in some situations. Okay, but first things first, two main topics, right, that overlaps with reasoning engine and why they are considered as similar solutions. Firstly, just now I mentioned that in the reasoning engine solution, right, I'm wrapping around Vertex AI search because I don't want to reinvent that search experience. Like what Google has already invented, they're doing it well, let's keep it that way. So that's the same thing for the Vertex AI SDK use as well, where I'm also writing code to wrap around this. I don't want to reinvent the base search experience. Okay. The second part is the same concept of function calling comes back again, because this is a function of using the Gemini model, okay, which services function calling. And it also allows you to build that customized search experience using the Vertex AI SDK, but allowing you to create your own tool to interact with Vertex AI search, or you can also create the other tools I mentioned just now, like being able to do a currency conversion or do a Wikipedia search. Yeah. Okay, but besides these two core similarities, right, I would say that there are quite a few benefits why personally myself, right, I would choose to go for Vertex AI SDK, and in some sense maybe vendor locking yourself a little bit, rather than going for a reasoning engine. Okay, the first thing is I would say it's because of benefits like being able to use the UI. I think right now reasoning engine we haven't really seen if they are going to go to the UI option yet, but being able to have access to the Vertex AI Studio. Like some of you might have used the Google AI Studio or Vertex AI Studio to be able to test your prompts, right? This is a very powerful tool for you to be able to test your prompts directly, see if this is something that works out for your product first, like based on the output. And then once you're ready to integrate it as an application developer, right, you can just click the Get Code button, and it gives you a rendered template of the entire code you should put into an application. Okay, it's not just code that you have to change variables here and there. You can actually just take this code, immediately put it in an application, and most of it should work. Okay, and it's also available in multiple different languages. So having that sort of that jumping board, a bouncing board, right, to allow you to immediately onboard into using Vertex AI SDK or Gemini model directly, right, it's so powerful with this UI tool. So that's one big difference why you should go with the Vertex AI SDK first. Another difference, and this one I would say is one of the most important things, is allowing you to have more control over how you use these models. Okay, so I call this the option to do singleton. Okay, this is a little bit of a hard concept to explain, but before explaining singleton, I need to first explain what is multi-turn. Okay, and the idea of multi-turn, right, is essentially as shown in this image. This is one image I took from Google Cloud's documentation. The idea of multi-turn means that you are sort of interacting with the model multiple times. You know, for example, in this case, what happens is, let's say, okay, you have a user, you have your backend application that you create, okay, and the user, let's say they're using a front-end application, and of course you have the model, for example, like Gemini. Multi-turn here, right, means that, let's say the user passed the prompt in, okay, your application, it doesn't run the model directly, right, but you'll use, let's say, the Vertex AI SDK. So you'll pass the prompt via the SDK to the model, okay. The model, right, sometimes will give you the answer directly, but sometimes they're not sure what's the answer, so they will invoke your functions. Like just now I mentioned, right, you put in your Vertex AI search function, so they'll tell you, okay, you need to go and call Vertex AI search and then give me the results. So they'll return that indication or that notification to your application through that response. And then in your application, right, your application is the one that actually does the search, right, like the API call to Vertex AI search to get the results. Okay, and then you'll get the results back in this response, which is the, let's say, the array results, and you'll pass this response back to the model, where they'll sort of summarize the results and return it back to you that you can give it to the user. So this is kind of like what's referred to as multi-turn. Like you call the model once, and then you call the model a second time based on like this one single flow. But some of you might, like if you are quite perceptive, right, you might see that using this on search may not be the best. Why? So let's say in this case, I call the model, I get the indication back that I should talk to my search engine, okay? And then I call the API to get the search results, right? It'll be in something like JSON, right? Like an array of JSON results. But if I get the array of JSON results back and I pass it back to the model, right, they're not going to give it back to me in the array of results. They'll give it to me in like some, like one, maybe like summarized to like one line saying that there's this products in the database. And that's not very useful as an application developer because we kind of want to render, let's say if this is for Shopee, for example, I want to render some results on the front end for my users. I don't want to render like something like a chatbot response. Yeah. So using the Vertex AI SDK gives you a bit more control where you can not do this multi-turn methodology over here, but short circuit it to single turn, which is if let's say the model tells me I should talk to my search engine, I'll talk to my search engine, I'll get the results back, and I'll just return it right away. But the whole reasoning engine actually wraps around the whole flow, and they don't allow you to, you know, sort of being able to short circuit and do this single turn process yourself. Yeah. So that's one very big benefit that I see using the Vertex AI SDK. Okay. So by doing singleton, right, essentially you can just display, as I said, right, you know, JSON results. So you can just display results like this rather than being able to be forced, rather than being restricted to just display like, you know, a chatbot-like response, allowing you to do more with Gen AI, you know, rather than just being able to just build chatbots only. Okay, there's a multitude of many reasons why you want to choose Vertex AI SDK. I just sum it down to these 3 top ones. And this last one I would say is that as an application developer, you get more support for other languages like Node, Go, Java, If you're building in reasoning engine, I think today you only have one choice, which is Python. I'm not going to survey you guys here, but I think for most application developers today, right, most of you wouldn't be building backend applications in Python, right? I think there's not a lot of frameworks that go for that. Maybe more for data science side of things, data analyst side of things, yes, but not so much for application development. More so in Node or Go backend applications instead. Yeah. So that's why I think Vertex AI SDK being supported in these languages gives you a lot more that you can do. Yeah. Okay, so rounding it up, hopefully with this half an hour, we sort of went through many different options on how as an application developer, you can use it to build your own products. And we have sort of run through sort of 3 different ways or 3 different types of technology they can use in Google Cloud to build your search-based applications. We started off thinking as an application developer, we have 3 options, but it's kind of like this in the end. You don't really want to rebuild the whole search experience yourself, but if you want to build for search, wrap it behind Vertex AI SDK or Reasoning Engine. Okay, and like I mentioned, there's a multitude of benefits, pros and cons. I'll share these slides later. Unfortunately, I don't think we have enough time to go through the pros and cons on each side. But as an application developer, I think it's important that you find out what's the right trade-offs. Sometimes tool A is better in a certain circumstance due to what your company is doing. So you should go for that. Sometimes tool B is better. Yeah. So find the right trade-offs that you're making there and the right choice that you should make for your company in building your products. Okay, let's maybe go into demo. So we're running a little bit low on time. So just want to show you a bit of demo in terms of the function calling, how it works. So let's say I have a fictional search engine that's not Google, but it's called Handsome. And then let's say I want to use it to search, maybe it's like something like Shopee where I can use it to search for some Google merch. Okay, so maybe I would type in Dino merch. Okay, and it should return me expectedly like a list of the merge-based results based on what I already created in Vertex AI search. Okay, so you can see over here, this is data that's put in the data store itself. I'm not mocking the results in any way. Okay, and maybe let me change this to something else to show you that I'm not. In fact, I actually put in something extra here. I link it to multiple data stores. So not just one single data store for merge, but I also link it to another data store for phone products. So let's say I put in Pixel, right? And the Vertex AI search is smart enough to know that, okay, I should call the other data store instead to get the right results from that data store. All right. Okay, and to make use of the concept of function calling, so what if, like I said, I'm not looking for any of these products, but I want to do a currency conversion. So let's say like this price over here, 699. So can I ask it to convert, say convert 699 USD to SGD. Okay, so this will make use of the concept of function calling rather than, okay, let me make this a little bit bigger, rather than calling the Vertex AI search, because this data itself is not inside the search engine. So rather than calling the Vertex AI search tool, right, you actually call the exchange rate tool that I created, that I link it to an external API. And then through the external API, I actually will find out what's the proper exchange rate here, do the calculation, and let Gemini know that, hey, you should return this response instead. And this is not data I'm saving anywhere. In fact, y'all can go and check to see if this is correct. Like this is not something that's, like the model is trained on this and like on past data where they are already outdated on this exchange rate information. This is like live data that comes in from an external API through function calling instead. Yeah. Okay. I want to show a little bit more demo. I'll try and finish in the next 1 minute. I know I'm almost out of time. Let me see. Actually, there is nothing much left. I think in a bit I'll show you the slides. But maybe just to show something a little bit more fun, because I'm an application developer, I want to also hack this together with Vertex AI SDK related tools, but not all using Gemini. For example, on a Chrome browser, you can also use the speech synthesis API as well as the speech recognition API if you want. So let's say, you can build a chatbot like this as well. Hello?
How can I help you?
Well, I feel like the next part, if I make it, if I do it, it will be a bit lame, but I'm just going to do it anyway since I already put in the time for this.
Tell me about Singapore.
Yes, sir. I will search for Tell Me About Singapore. Singapore, officially the Republic of Singapore, is an island country and city-state in Southeast Asia. It is a highly developed...
Okay, yeah, that's a little bit too long. Okay, one last one before I finish, because I've run out of time already. Since I put an Easter egg in here, just to make, like, hopefully it's funny. Am I handsome?
Yes, sir. You are very handsome. In fact, everyone here at this event is handsome.
Okay, anyway, just trying to make this a little bit more lighthearted and fun. But anyway, I hope this sharing has been enlightening in terms of the Vertex AI tools that you can use to create your own applications, not just for search. There's a lot of code that I cannot share, unfortunately, in this very short session. You can take a look at the code base that I created over here for using Reasoning Engine, Vertex AI SDK, both in Node as well as in Python. And if you want a reference to these slides, you can take a look to it through this QR code as well. I'll share this online via LinkedIn later on as well after this. Okay, I'll wait for a little bit for everyone to be done. Okay, I still see some folks taking photos. Okay, anyway, yeah, I think that's that for my sharing. I come just to advertise for my company a little bit. I come from this place called Ascenda. We're always looking for people to help us build really kick-ass loyalty platform services. Yeah, so if you're interested, you can reach out to me. I think later on, we also have another speaker from Ascenda at the Women in AI panel later on. But yeah, do talk to me if you have any, if you're curious about what we do in Ascenda for jobs or regarding the sharing that I did today as well. But anyway, yeah, thanks for your time. Yeah, let me know if you have questions.
Thank you, Wei Yuan, for a enlightening and a handsome session. Okay, before we take a break, I have two things from my side. Okay, one is lost and found. We found a headset. I don't know how to call this. If you think this is yours, please come on up to the front during the break time and then find me. And then the second one, it's exciting announcement. We have a surprise guest speaker who wasn't included in the agenda earlier. So today we are delighted to welcome Nenad Tomasev, a senior staff research scientist from Google DeepMind. He'll be joining us here in the dev space shortly after break, so please stay tuned. Okay, now we'll take a 15-minute break. Please be seated by 408 so we can resume the sessions. Thank you all. And as we head into the break, we say farewell to our live stream viewers. Thank you for joining us today, and then we hope to see you at DevFest in the future. Thank you, everyone.